All right, so just to review how to solve a two-step equation, first you want to undo any addition or subtraction, and then the multiplication division. So for number one, we want to undo the plus 7. So we're going to subtract 7 from either side. Which would leave us with 2x equals 6. Then you're going to undo the multiplication or division. In this case, you'll undo multiplication by dividing both sides by 2. And then you'll have x equals 3. Right? So once you do enough of these two-step equations, I almost think of like once you get your equation down to this setup, you almost kind of go on autopilot. Right? You're just doing the same thing in every problem where you're either adding or subtracting and then either multiplying or dividing. So like in number 2, we want to take care of that plus 9 first by subtracting 9 on either side. Then I'm left with this fraction, which is really k divided by negative 4 equals negative 11. Yes, what will I multiply on both sides? Negative 4, right? Good, so I want to multiply negative 4 on either side. So I get k equals positive 44, good. Let's do one more little warm-up problem here. Here, most of the stuff is on the right-hand side of the equation. That really shouldn't change anything about how you solve this. You know, at the very end, I might swap it just so I put my variable first, but other than that, the steps are essentially the same. We're going to start by adding 6 to both sides. So let's see, negative 15 plus 6. This might be a good time to use a calculator. Negative 9, okay. So negative 9 equals negative 3x. Then we could divide both sides by negative 3 and get x equals positive 3. Now, in these simple equations, but also in the more complicated ones that we'll do today and moving forward, you can always check to see if you got the right answer. In fact, you might want to get in the habit of doing this every single time you get an answer so that you know right away if it's right or wrong. Okay, how can I check my answer? How do I know if 3 is right?
Calculator. Substitute.
Use a calculator, but like you got to know what to punch in, right?
Substitute the variables for the answer.
That's exactly right. You want to take your solution and put it back into the equation. All right? So how do I check my answer? Substitute your answer back into the original equation. For example, if I look at that number 1, right, my solution was x equals 3. If I go back and plug it in, 2 times 3 plus 7, does that equal 13? Yeah, so you know you got it right. So you want what is new about the problems below? Well, just exactly what I just said, where you have variables on both sides of the equation. So I'm just going to see if I can squeeze that in here. There are variables on both sides of the equation. Okay. So in terms of like at what time do you actually perform the step to move it over, I kind of like to think of it as sort of the second half of this combining like term step. So you do still want to simplify both the left and right hand side as much as possible, but then you want to look to see if you've got like other like terms that you can move over. Yes, sir?
So wouldn't you just add 3 then to 6?
Yes, yeah, exactly. So like for this first one, just like you said, we want to move over the 3x. So notice how both the left side and the right side are already simplified, so we don't have to do anything like that. So we're going to go ahead and add 3x to both sides. Now, how do you know whether or not to add 3x to both sides, or how did I, why didn't I add 6x to both sides? Yes, sir.
Because it's taking, if you add 6x to the other side, then you don't have any other variable on the other side.
Right, and which is okay, like from a technical perspective. What you would end up with is just 0 on that side, but you will end up with an equation that has more steps. Right here, you're sort of consolidating 2 steps in one. But if you were to move, the 6x over here, then you're still going to be left with a 2-step equation. Yes, sir. In the back.
How did you change it to 12x?
Oh, right. Yeah. There. No, there's no x on there. My bad. Thank you for pointing that out. That's what happens when I'm like talking and writing at the same time. You should get 12 equals negative 3x. Are y'all okay with that? So now that we've got it down to a 1-step equation, we want to divide both sides by negative 3. And so this is, let's see, 12 divided by negative 3 is what? Negative 4, thank you. So we got x equals negative 4. Now with number 5, you can see that both sides of the equation are already simplified, right? There's nothing to combine or distributive properties. So the next thing to recognize is that we have variables on both sides. And so we want to move one over to the other side. And we basically have 2 options here. We can subtract 3k from both sides, or we can subtract 8k from both sides. Now, it doesn't really matter which one you do. However, that being said, if you pick sort of the quote-unquote right way, you'll end up with a positive coefficient, which might be a little easier to deal with. So with that in mind, do y'all want to subtract 3k from both sides or subtract 8k from both sides?
3K.
Yeah, 3k is probably the way to go, just so you can avoid having to deal with the negatives, right? So I'm going to subtract 3k from both sides. Now, if you sort of missed that and you just decided to subtract 8k from both sides, it's not a big deal. You'll just have a negative coefficient on that variable. Here we've got 45 equals 5k plus 25. So now we've got it down to a 2-step equation, which you guys are very good at. It's on the quiz today that most of y'all got those 2-step equation problems right. Feeling pretty good about those. So we get 20 is 5k, and so my last step, just kind of going down the list of steps here, it's going to be to divide both sides by 5. So I get 4 equals k, so k is 4. Yes, ma'am.
I did subtract 25 at the beginning, and I still got the same answer.
Yeah, that's fine. You could do that. As soon as both sides are totally simplified, like independent of one another, you do have a little bit of freedom as far as like what you want to subtract over first, which is good because then you can't really mess it up. Like at this step, if you start really knowing what you're doing, you can actually do 2 steps in one here and actually knock both of those out at the same time. In other words, do what you did, which is like to subtract 25 on both sides, but simultaneously subtract 3k from both sides. And you'll sort of knock out 2 terms at once instead of just one. And so yeah, you could do those like one at a time. Like for now, I'm probably gonna just do it one at a time, just to really emphasize the different steps. But it sounds like you kind of know what's going, you kind of get it. So yeah, do them both at the same time if you need to move stuff over. Yeah, that's very good. Number 6. Should we subtract the 2p or the 5p?
2p.
Probably the 2p, yeah. In some cases, it doesn't really, you're not going to get much of an advantage out of subtracting the smaller one, but, every little thing we can do to make this a little easier would be helpful. So we get 3p minus 9 equals 12. Or, like you were saying on the last one, we could add 9 to both sides too, which is what we're going to do anyway on the next step, right? So if you want to do both of those at the same time, that'd be awesome. Plus 9 gives you 3p equals 21. Ooh. Right? Yeah. Divide both sides by 3. So we get p equals 7. So hopefully you're starting to see that, you know, when you have variables on both sides, it's not a huge difference from what you were already doing. You just want to be aware of how to do that. What I usually see, the kind of mistakes that I see is like, people will want to just like combine those like they're like terms on the same side. You just want to make sure to avoid that. All right, well, let's take a look at some harder ones, yeah? You know, we sort of already answered this question. Does it matter which side of the equations you move the variable to? Well, yes and no, right? It doesn't really matter in the sense that, like, if you add one versus adding the other, you're going to get it wrong. That's not really the case. But you'll probably be less likely to make an error if you have fewer negatives going on in the equation. You know, dividing by a negative or adding negative, all that kind of stuff. You want to sort of avoid if you can. So does it matter which not really, but you know, one way might be easier than the other. So like in number 7, should I add 3r to both sides or subtract 15r? I think adding 3r is going to make this just like a slight bit easier. Yeah, it's probably easier to do mentally also, right? 3 plus 15 versus negative 3 minus 15. You know, one's just a little easier to do in your head. So let's add 3r to both sides. So we get 10 equals 18r minus 8. Then we can add 8 to both sides. Oh, this is going to work out pretty nice. Right? 18 equals 18r. So what's r? 1. Yeah, you guys are a step ahead of me. This is good. So yeah, divide both sides by 18, you'll get your solution. Number 8 is very similar. Just want to kind of think about which movement will make this easier. So yeah, let's subtract 2n from both sides. (5n plus 3 equals 23). We want to subtract 3 from both sides. Once you get it down to a 2-step problem, you should be good to go. You're doing the same kind of steps on every single problem. Last thing is divide by 5. So we get n equals 4.